we always tell you to maximize your test screen so it takes up the whole screen. The reason for that is any pop-up screen that comes up is a proportion of the size of the screen you have. So since you're going to be trying to enlarge this graph, to be able to graph on that, we want this graph to be as big as we possibly can. If you have problems seeing, and you did that with your graph, and you click to enlarge your graph is going to be so small that you can't even see it because I made it too big. Okay? So now I got to find out if I can get rid of this. Okay, so look at that. Look at the size of my viewing window over here. My viewing window is tremendously small. Do you think you're going to be able to draw a graph inside of this small viewing window? No. It's going to be kind of hard, right? Okay? So no, the problem is that you can't do anything with this window. There's no maximization for it because it's tied to the size of your screen. So if you are one that has a problem with needing big print, for the graphing problems, you might want to do something like this and make it a smaller window, a smaller print, because now when you enlarge, I get a bigger graph. If I make it even smaller, and you're beginning to say, God, it's beginning to look like Bible print out there, but if I enlarge it, look at the effect on the graph. So it's an inverse relationship that sits out there. Okay, so irrelevant whether we left it that way or not. Somewhere in between too big and too small, there's going to be a just right, but there can be a too big and there can be a too small for you. Okay, so you follow directions. We graph, we click the graph, and it enlarges. They said click the graph. I don't really need to click the graph. I can click the graph and nothing's happening. I click the enlargement for the graph. Now I know that these are all linear equations, so I'm going to choose the tool from the palette, which is visually a linear relationship. And it's going to tell me, click the graph and plot the first point on your line. Well, if I do intercepts, those are a lot quicker and easier to be able to get. So one of my intercepts, if x is equal to 0, we found out that the y value was what? If x is equal to 0 on the top equation, then the y value is 8. So I need to have, with this active, oh, by the way, look at that in the upper right-hand corner of that yellow bar. What do you see?
Numbers.
Ordered pair. Guess what? If you can't plot that first point where it belongs, you got a bigger problem than I can handle. Sorry, don't mean to be insulting, but you should never have made a mistake. If the tree, that screen's kind of small, but that's the point 0 and 8. And now its companion point, oh, by the way, look at that. The line's alive now. Okay? All I need to do is know where the second point goes. Where's the second point for that line supposed to go? 4 and 0. So now I adjust it so it goes through 4 and 0. And there's my first line. Now I'm ready for the second line. Well, second line, you got to go back and pick a new line to it because you're done graphing the first line. Now you're looking at your second line. What's the first point on the second line? 0, -4, or 1, 0. Does it make a difference which one's first and which one's second? No, not at all. So 0, -4, 0, -4, and the other point was 1, 0. And we nail it down, and it says, we save it, and we check it, and it says, oh, wait a second. Graph this by finding distinct points. Oh, it's not the same problem. Well, that makes a difference, doesn't it? Okay, so let's, oh, that's great, because that's wonderful. Okay, so I'm going to enlarge this graph again. I had 3 options. To hell with this, I can't do this, I quit. No. Erase this crap and start all over again. No. Because if one of the lines is in the wrong place, all you have to do is click the line and change where the corner points are. So up here, if x is equal to 0, then y should be a -4. If x is equal to 0 on my first line, then y should be at a negative 4. And if y is equal to 0, then x should be, okay, it's supposed to be a negative 4. Okay, so we come back and we take this again. We drag it to a negative 4. Okay? And the second point on this line that I was dragging, if y is equal to 0, then x should be a value of 2. So if y is equal to 0, x should be a value of 2. And I can see that that's at 2, 0. Now, if the first line was wrong, then the second line is probably wrong too. So let's come back and look at the second line. Okay, so if x is equal to 0, then y has to be a value of 1. So if x is 0, y is a value of 1, which I'm very sure that I get in the right place. And if y is 0, then x is a value of positive 2. So now I know I got it at the right place. Now I can say, now I can check, and now they're happy. Now, here's the problem. They want to know the solution. They want to know what this point of intersection is. And if I enlarge this graph, I might be able to read the point off of the graph. It isn't always going to be a nice whole number. Most of the time it will be a nice whole number. But if we're graphing by hand, probably ain't going to be looking like a whole number out there. Well, what if I think it is? Well, what does it look like this point of intersection is? 2, 0. Should I be able to check that? Well, we already talked about checking the equation. So if I go back to the equation, and I can slide this window over a little bit. Okay? So back to the equation. If I think that 2, 0 is the proper solution, top equation, 2 times 2 is 4, 4 minus 0, 4, check. Bottom equation, 0 plus 2 times 2, or 2, excuse me, 0, 2, 0 plus 2 times 2, 0, 2, 0, excuse me, 2 for x, 0 for y, so that gives me 2 plus 0, which is 2, check on that one, so that's the right solution. You might be able to read it off the graph. You may not be able to read it off the graph. So since we don't have reliability of that all the time, we would much prefer, and I know my solution up here is going to be an ordered pair, so they want it as an ordered pair, and we always know that x comes first and y comes second, and you got to close the grouping symbol. So some of your problems are two-part problems.